Hello class, so here's some helpful hints for problem number 90 from the homework. This is a good and tricky problem. So, as you can see here, I started off by drawing a picture where we have our penguin who's starting on the slope up here, and he's going to be sliding down the hill at a constant velocity until he reaches the bottom, at which point he will slide along the ground with not the constant velocity, because eventually he'll come to rest at some location where we know his final velocity, if he comes to rest, is going to be 0 meters per second. So what we're told is that our v is constant up here on the slope, but we now know that it's not constant once he is on the ground. And so really there's two parts to this problem. So we could almost divide it in half, cutting things right about here, so that you have an initial part where he's sliding down a slope of an angle theta with a constant velocity, and then a second portion where he's on the ground, the flat ground, where he has some acceleration during this point, which we do not know. Because if we think about what we're asked for in this question, in this problem, we're really asked to determine how much time it takes for him to reach, come to a halt at the bottom of the slope, right? So we're trying to determine the time, and in order to determine that time, we're going to need to figure out a few other things first. So to determine time, and with being given the initial velocity and the initial angle, we're going to also need to determine what the coefficient of kinetic friction is between the penguin and the slope, and we're also going to need to figure out probably what the acceleration is of the penguin. Okay? So let's go ahead and label the two portions of our motion. Alright, so let's go ahead and call this first part, part A, and the second part over here, part B. So considering part B, okay, if we think about what's going on for part B, that's where we're going to be able to determine our time. And we can even use a simple equation of motion. Since we know the initial velocity, we know the final velocity, and if we can find acceleration, we can just look at part B and say, okay, well, from part B we know the final velocity is going to be equal to our initial velocity plus our acceleration times time. So we know initial and final velocities. If we find acceleration, we can then determine the time. So the question is, what is the acceleration? Well, the rate of acceleration during that time where he's flat, let's look at that a little closer. So let's draw a free body diagram. Alright, well that's a box. He's not a box. This is a penguin that we're talking about. So if we draw a penguin here, might as well give him a beak because he's a penguin. Okay, there's my penguin. Alright, if we consider the forces acting on the penguin, what do we got? Well, we know in the negative direction, we got the force of kinetic friction. Okay, and we know in the y direction, we're going to have the weight force going down, and the normal force in the upward direction. So looking just at the x direction initially, we can see for the flat part again that the sum of the forces in the x is going to be equal to mass times acceleration, right? So the question is, what forces are in the x? Well, the only force in the x is our kinetic force of friction, and that's equal to the mass times the acceleration. And if we recall, kinetic force of friction is equal to the coefficient multiplied by the normal force. So in order to be able to solve for our acceleration here that we want, we need to know what the coefficient of friction is over here. That's kinetic, so we'll leave that. Okay, so then what you need to do, before you can use part B to solve, before we can use any of this stuff here, we need to look at what's going on in part A. So let's go to part A. Once again, we're going to need a free body diagram. So we got our penguin. And our penguin is at an angle. Okay, I'll give him the beak again, because why not? Okay, that makes all the difference. Anyway, we got the penguin, and so what forces are acting on him? Well, we know that he has his weight force, as always, going straight down. and then up the length, there's going to be a force of friction. The same force of friction because we're told the coefficient stays the same. And then we also have the normal force. Alright, so in order to solve this, we need to define axes. So if we define our x-axis as parallel to the source and our y-axis as perpendicular, then we can use this to try to solve. Again, if we look at some of the forces in the x direction, we're going to immediately be able to see that our weight force is going to have an x and a y component, right? So our weight force in the x direction, you can see, is going to be equal to the weight force multiplied by the sine of the angle, and the weight component in the y direction is going to be equal to the weight force multiplied by the cosine of the angle. So you can set up the sum of the forces from here and see if you can possibly solve that for your coefficient of kinetic friction. So again, sum of the forces in the x direction in this case, before they're equal to ma up here, right? But at this point, we're told, let's review, that we have a constant velocity. What does that mean? That means that the net force is equal to 0, Newton's first law. So if we do sum of the forces in the x direction, we have wx in the positive direction, this way, and we have minus the force of kinetic friction in the negative direction, and that's equal to 0. Alright, so what you can do then is you should be able to use this information in combination with sum of the forces in the y direction equal to 0 to solve for your coefficient of friction. So I'm not going to solve it all for you guys, but you should be able to use part A to find the coefficient of kinetic friction, get some number for that, and then from there you can go back up and use your information in this first part to find your acceleration, and then once you have your acceleration, you can use equations of motion to find time. Lots of steps, crazy problem, but also lots of fun. So best of luck, hope this helps. Let me know if you have any questions.